Okay, so now we're going to talk about quadratics with a real life situation. There are two problems that are very similar to this on your Target 4 homework, in that we ask you all of this information of the vertex, axis of symmetry, concave up, and so forth. Okay, so here's the situation. A cannonball is launched from the ground 5 feet behind you. It reaches a maximum height of 8 feet and lands 3 feet in front of you. So what we should do is make sure that, let's assume that you are standing on the origin. And I'm going to make you a little smaller. So you're right here standing on the origin, okay? And all we know is that it launched 5 feet behind you. So let's assume we're facing forward in the positive axis. It's going to start 5 feet over here. So that's our first intercept. And it lands 3 feet in front of you. Well, this is our other intercept over here. Okay. Now here's the confusing part. It reaches a maximum height of 8. So that's not our y-intercept. Okay, I can't just put a point in here, but rather remember that quadratics are very symmetrical. So if this are my two intercepts, that means from here to here is a distance of 5, and from here to here is a distance of 3. So my middle, my vertex, is going to be exactly in the middle of that whole thing. So if I take 5 and 3, I have a distance of 8. Okay, which means that 4 away from my intercept or 4 away this way should be the exact middle. So if I count 1, 2, 3, 4, the vertex is actually going to be at -1. -1 is actually the middle of this quadratic. So I'm just going to draw my dashed line in here. So I know that it reaches a maximum height of 8, which is way up here. Okay, and so I can actually now draw the line in that the cannonball is going to go up and come back down right there. Okay, so let's fill in some of this information that we now know. Okay, so our vertex is, let me type a little bit bigger for you. Our vertex is at -1. Come on. -1, and it reached a maximum height of 8. And again, we found this -1 by knowing that our intercept is at -5 and 3. And so the distance apart is 8, which means the middle has to be 4 away, and so we counted 4. Our axis of symmetry is always x equals, and it's the number where your vertex goes through. Okay, our cannonball is going up, and then gravity is bringing it down. So our graph is actually concave down. And because it's concave down, we have a maximum. It also says a maximum in our problem, so we know that as well. The y-intercept, I don't know that we know that yet. And the x-intercept we do. Our x-intercepts are going to be the givens, in that we started with an intercept of x equaling -5 and x equaling 3. Okay, so in order to find the y-intercept, we're actually not really sure where it crosses. We're going to find the equation first. So remember to find your equation when you do y equals a times, our vertex is at -1, so I'm going to do x plus 1 squared, and then it's up at 8. So in order to find a, I need to pick any other point. We don't know any of the other points except the intercepts. So I'm going to use this intercept here of 3, 0 in my equation. Okay, so I'm going to do y is 0, a, I'm trying to find 3 plus 1 squared plus 8. So I'm going to subtract 8 from both sides. And this 3 plus 1 squared, 3 plus 1 is 4. 4 squared is 16. Okay, and so when you divide, -8 divided by 16, you get a to be -1/2, which makes sense. So now, my equation is y equals -0.5 times x plus 1 squared plus 8. Okay, now that I have my actual equation, I can find my y-intercept by plugging in 0. So I'm going to change colors here and plug in 0 for x, negative 0.5, 0 plus 1 squared, plus 8. Okay, so again, I'm plugging in 0 for my y-intercept, and when you do that, you get 7.5. So now I can go over here and say that my y-intercept was at 7.5. All right, so again, what you had to do is you had to read the problem, draw a picture of what you know. I had to find the middle of the graph, knowing that quadratics are symmetrical, and then that told me my vertex and my axis of symmetry. The x-intercepts were easy this time because that is my starting points, whereas I had to find the equation of the parabola in order to be able to find the y-intercept. So let's try one more very similar to this. Let's talk about Tarzan. Tarzan starts on a tree branch 3 yards behind where his rope is attached and swings 6 yards below the tree line to another tree, same height, 3 yards beyond where his rope is attached. So in this problem, let's assume that the rope is attached up top, okay? You actually don't know where, how high his rope is. We just know that it goes 6 yards below the tree line. So this one's a little bit tricky. Let's, for the sake of this, assume that we wouldn't want to hit the ground because then your bottom would be, touching the ground when you swing. So let's assume that our rope is going to be attached in this midline, okay? And we know that he swings 6 yards below. So if I don't want to hit the ground, I'm going to start here at 1 and actually count 6 up. 1, 2, 3, 4, 5, 6. So that's at 7. So I'm actually going to assume that my Tarzan guy is the rope is attached up here at 7. Okay, so Tarzan starts at a tree branch 3 yards behind where his rope. So 1, 2, 3. That's over here. Okay, and he swings 6 yards below to the other 3 yards in front over here. Okay, so I know that it's going to go all the way down here and go shoo, swing and come back up. Okay, does that make sense? So I didn't want to put it on 0, 0 because then it's not really realistic in that his butt is going to hit the bottom. Okay, so I put it 1 foot up, but it's 6 feet high from side to side and 3 feet away from the rope and then 3 feet on the other side of the rope. Okay, so let's see if we can now answer some questions here. If I wanted to know the vertex, I made the vertex at 0, 1. Nowhere for x and up at 1. You could have made it at 2, at 3, at 4, at 5, as long as it was higher so that he could swing 6 below. So the axis of symmetry is x equals 0. We are going to circle concave up, and we are going to circle minimum. Okay. In this problem, it's actually a lot easier to find the intercepts. It's because it's what I created. So it is going to be 0, 1, the same thing as the vertex. And in this situation, you'll notice there are no x-intercepts, which makes sense. There at no point is Tarzan going to hit the ground, so there are none. Okay. And then the equation, we can find it by doing very similar things. Y equals a times x minus 0, because it wasn't shifted anywhere, squared plus 1. If I want to find a, then I have to use one of these starting points that I started with, which is 3, 7. So 7 for y, a, x minus 3 squared plus 1. I'm going to subtract 1 over and get 6. And I forgot to plug in the x, which is 3. So 3 minus 3 Is x 3? Yeah, x is 3. 3 minus 3 squared. Oh, I plugged it into the wrong spot. So, whoopsies. All right, let's start over with that equation. All right, so y equals a times x minus 0 squared plus 1, right, for the vertex, 0, 1. And then I'm plugging in the point 3, 7. So y is 7, x is 3, and then plus 1. Okay, so I'm going to subtract 1 and get 6. 3 minus 0 is 3. 3 squared is 9. Okay, and then I got to divide. 6 divided by 9. So a is going to be 2/3. Or 0.666666 if you took 6 and divided it by 9. Okay, so I'm going to go over here and actually write the equation of the parabola y equals, text box, y equals positive 2/3 x minus 0 squared plus 1. Okay, so there are two problems like that similar to your homework.